simplify the following. So we're just using our exponent properties to make sure that we can simplify these three problems. I'm going to give you a certain amount of time to do this. If you can get through 1, great. If you can get through 2, great. If you can get through 3, great. Just about getting the practice in that we need, right? I'll go over them after a little bit, but go ahead, start. You can even start on the one that you think looks the most fun. You know, it doesn't necessarily have to be the first one, okay? So I'll give you some time to work. Also have your homework out so I can check that off while you're working, okay? All right, so first one. Well, I see parentheses to a power, right? Everything in the parentheses gets raised to that power, right? I got 3 to the 1, I got x to the negative 2, it's all being raised to the 2, right? So you can just think of it as 3 to the 2 or 3 to the 1 to the 2, which is still just 3 to the 2. Right? So I got 3 to the 2, and then x to the negative 2 to the 2. Negative 2 times 2 is? Negative 4. So x to the negative 4. And then this is 3 to the 1, x to the 1. Now, you don't have to write those to the 1, but 2 reasons to do that. 1, it reminds me that even though they don't have an exponent, they really have an exponent, right? It helps me to not just treat them separately. Also, in my next step, now I have exponents to work with because I have to start combining things, right? And when you start combining things, right, you could take the time to put them together and say, well, let me go 3 squared times 3 to the 1 times x to the negative 4 times x to the 1, if it helps you to see them side by side, to know what you can combine. But you don't have to do this, right? Just when you're multiplying things, you can, if everything's multiplying by each other, you can combine pieces along the way. They don't have to be next to each other, right? So you kind of do like the like terms type deal where you can use the underline method. This and this can go together. This and this can go together. So 3 to the 2 times 3 to the 1, that's 3 to the third, right? And x to the negative 4, x to the 1, add those together, you get x to the negative 3. Okay. Once you have just a number, just a variable, right? Nothing left to combine, you're pretty much done, except you always check to see if you have a negative exponent, because we don't like negative exponents. We don't want them to be negative. We want them to be happy and positive, right? So we don't leave them in our final answer. We move them to a more positive place, right? So what we do is we set up some floors, right? Top floor, bottom floor. And we ask ourselves, okay, what needs to move to become more positive? And I guess I should say everyone starts in the top floor. So what wants to move? X to the negative 3 will go down. Yeah, it's upset. It wants to get positive, right? 3 to the 3, is that upset? No, it's fine. It's staying here, right? And you can make that 27 over x to the third, but that's your answer, okay? Make sense? Okay, next one. Here I have x to the negative 2 to the 3 over 3x to the negative 2. So again, I want to deal with that parentheses. And I get x to the negative 6, right, over 3x to the negative 2. Okay, couple options here. I've always told you, if you got stuff on the top, you got stuff on the bottom, do the quotient rule to bring it together. I will say that if you feel like that just messes me up because it's negatives and minus and negative, you can move right now. You can move stuff top floor, bottom floor if you want to. I'm going to show you that in the next example. I'm going to do it the way that I've been talking about it. All right, so the 3, is that going anywhere? No, it's being raised to the positive 1. It doesn't want to move, right? So leave it. There's nothing to do with it. Now, on the top, I'll have x to the negative 6 minus negative 2. And a minus minus is a positive, right? So it's actually plus. So then I get x to the negative 4 over 3, right? Same thing as last time. All the x's are combined, all the numbers are combined. I just do that little who's unhappy, who needs to move, right? What needs to move? X to the negative 4 has to go down and become positive. Is a 3 moving?
Nope.
No. So then there's nothing left on the top. 1. Okay? All right. Last one. Here we go. Looks awfully similar. There's something in there, though. X to 0. So this all goes away?
No, just the x.
No. Very good. The only thing being raised to the 0 is x. Be careful to not do it to the attached numbers, right? 4 is being raised to a 1. Leave it alone. This becomes 1, right? So it's 4 times 1, so it just kind of goes away. So, okay. Remember I told you I'd show you a different way. Well, if that like last problem where you had a negative minus a negative kind of trips you up, you also could move stuff right now, right? You could say, I'm going to make these things positive right away if I can. So what needs to move? Both of the negatives, right? So the x to the negative 2 goes down. The x to the negative 4 goes up. And I end up with x to the 4 and x to the 2 positive in each situation. What happens to the 4?
It stays there.
It stays there. Okay, well now I still need to do that quotient rule, right? So I have x to the 4 minus 2 over 4, or x to the 2 over 4. Okay? Now, you could have done it the way we've always done it, which is you could have said x to the negative 2 minus 4 over 4, and then you just do that math, and you get x to the positive 2 over 4, and you get to the same answer in a little bit fewer steps, but maybe it's less confusing to do the first way we did it. It's up to you. Make sense? Ready for the next questions? Okay. All right, next skill is, hey, can we evaluate these? And evaluate means? No. Solve means find something that makes it true. Evaluate means just find the value. Do the operation. Find the value. Okay? So, again, got to know how to convert. I don't know how to do this. You're not supposed to be using a calculator for this, right? So I got to be able to convert this to a form I can use. So I got to think, what's my exponent? What's my root? Change the form, then think it through. Evaluate it. Okay? I'll give you a minute or so to do that. So if I'm looking at this, I think, what's my exponent? What's my root? Right? Where do the roots fall? On the bottom like a tree. Okay, so then I make this the 5th root of 32 to the 4th. So it's asking me what number times itself 5 times gives me 32. Yeah.
Do we always after them parentheses?
Yes, I would do that. It's just helpful. All right, so that's 2 to the 4th. And 2 to the 4th is 16. Okay? All right, again, you want to be able to think that through without a calculator. Okay, this one, well, this would be the 3rd root of 512 squared. Now, the 3rd root of 512, a number to the 3rd, that's 512. Where could I find that information? Right over there, right? What number to the 3rd is 512? 8. So this is 8 squared, which is 64. Make sense? So that's skill number 2. Okay, next up. Okay, can we rewrite these either from exponent form to radical form or radical form to exponent form? We kind of just did that a little bit, but both of these have a little trick in them. Both of these problems were problems from last year's quiz that a lot of people just messed up on by not being careful. So I'll just say be careful, okay? And this is your opportunity to catch yourself before a quiz, okay? So be careful, think about what you're doing, and just rewrite them in another form. There is one that you could evaluate a little bit. That's your extra points if you want to do that. But I'm just asking you to rewrite right now, okay? so this is what I'll do. I'll show you what everybody did on the quiz, and you'll tell me what I did wrong. Ready? All right, so we got root. We got exponent. So, oops, I forgot to put a little 7 in there. 7th root of 3x to the 5th. No. What?
Only x goes in the root thing because there's no parentheses around the x and the 3.
Very good. This is being raised to the 1. There's nothing happening to the 3 that would cause it to get rooted or anything, right? It's like you have 3 times x to the 5/7, right? So this 3 doesn't go in here. It goes right out there. It stays 3. Okay? Just be careful with that. All right, so the next problem is kind of like the opposite version of that. And, you know, same deal. You kind of want to know root, exponent. And I would actually add a piece here, and you could do this for both types of problem. What's my base? Like if you did this for the last one, you would have just said x, and it would have helped you catch this, right? So what's my root here? It's a square root, so that's 2. And what's my exponent? 3. And what's my base?
4x.
The whole thing, right? So, again, I'll make a mistake, and then you'll all yell at me. Ready? 4x, and then the root is 2, exponent is 3.
Absolutely. No, the parentheses.
So this is saying 4 to the 1 times x to the, this is just the same mistake backwards, right? I need the whole thing to be raised to the 3/2. Okay, so just be careful with both of those situations, right? What are you saying? Now, you could evaluate this. Anybody know how? Yeah. You got it. Okay, so when you raise 2 things in parentheses to a power, right, it applies to both of them. So you could say that this is 4 to the 3/2 times x to the 3/2, right? And 4 to the 3/2 we could do. We turn it back into a radical. Square root of 4 to the 3rd, x to the 3/2. Well, what is square root of 4? 2 to the 3rd is 8. So I have 8x to the 3/2, right? I didn't ask you to evaluate, so that's okay. You wouldn't have lost points there. But you might get a problem like that too. Are we ready?
No.
Are we ready for the warm-up problem that I was so proud that I came up with this morning?
I'm not happy.
There you go.
You think you're so smart.
What is that?
Now, don't worry about that pi. Treat it like it's x. It's just there because it's pi day, and we wanted to include pi.
Oh my god.
Okay? You can do this. You have the skills. Everything on here is something you could do. Okay? It's just a little more complicated than you're used to. And it actually will get quite simple. Just give it a shot.
You should be. This is very clever.
Thank you. Appreciate it. All right. We ready to see it? Do we want to keep trying?
No.
It's just
I got stuck in the center.
All right, let's do it together. Okay, first of all, square root of -1 is what? I. So let's make that I. Let's just get that ugly thing out of here. All right, and then we got all this stuff, but we're just going to worry about power to a power 1 at a time. Okay, so let's do one of them. So what is 2 to the 3rd? 8. So I'll just say 8 pi, and then 2 to the 3rd, 2 to the 3rd to the 4 to the 3rd would be, you'd multiply those. So that's what? 2 times 4 is? 8. And then 3 times 3 is? 9. And then that's being raised to the 9/8. Okay? So I got I, and then I'm going to do that one too. So I have 8 pi, and then what's 9? 8 times 9?
72.
And what's 9 times 8? 72. Oh, I got 72 over 72. What's 72 over 72? 1. Okay, so this is just I, 8, pi to the 1. Anything to the 1 is just...
Oh my god, we're just
What do we?
Wait, I need to take a picture of this. My parents are gonna love this.
I'm sorry. I couldn't resist. I ate pie. Anyway, okay, so that was fun, I hope. But there's also, the best part about it is it ties in today's lesson.
Oh, God.
Because, watch this.
No.
Same thing you just did. Watch. Ready? If I had x to the 3/4 equals 100, and I asked you to solve that, well, it's kind of hard because I don't really know how to get x by itself. But I kind of also do now because I just figured out what happens to get rid of exponents, or what I need to do. Right? This all became something to the 1. How? What was the step that made it something to the 1?
It was multiplying the fractions.
By their opposite, right? And that will always happen when you power to a power, right? So, if I just go and raise this to the 4/3 and raise this to the 4/3, well, what will I get? I'll have x to the 12 over 12 equals 100 to the 4/3. And then that's x to the 1, that's just x. And then I can figure out what that is, and now I can solve it for x when it's got a weird, crazy exponent, right? So, yes, I'm glad, I hope you enjoyed that, but also notice what happened here, because that's where we're going today, okay? That's what we're doing. Cool. All right, so we can dive into the lesson unless we feel like there are still problems on the homework that are confusing that we want to ask about, or we can do the lesson and ask questions at the end. Lesson? Because I feel like this will tie right in. So let's go. All right. Okay, so we got to talk about solving. That's what we're doing, right? I gave you a quick example of kind of like the end product here. But let's start at the beginning. Let's talk about solving when we have weird exponents or just exponents that we're not used to. Like we've really only gone with squared so far with solving, right? So we'll start there with our example. But before we do, let's just talk about the word solving. And I'm going to bring this up pretty much every unit. Because every unit, eventually we get to solving, right? In the linear unit, in the exponential, in the quadratic, right? We always eventually solved, right? And every time I ask you, what does it mean to solve? To find a solution is to what? To find what makes it true, right? Always remind yourself of that. We are still looking for values to make something true, right? This equation, we want an x value that will make this a true statement, right? Yes, we give you strategies, and they're different for every unit. In this unit, you do that. In this unit, you do that, right? But we always have the same goal in mind. Find the value that makes it true, and usually the thing we have to do is get the variable where in order to find it. What do we usually need to do with the variable to find that value? Sometimes we divide, sometimes we add, sometimes we square root, sometimes what? We're just trying to get that thing by itself. Isolated by itself, right? So that's still our goal. If I can get x on one side by itself and a number on the other side, well, then I'll find out what makes this equation true, right? So that's always our goal, right? So if you want, you can write that. Solutions make it true. Just remind ourselves. Now, why is that super valuable to remind ourselves? Well, it's always good to understand what we're doing. But let's say you get this problem. I'm asking you to do something for vertex form right now. We haven't done that in a while, right? This was a test. Well, what could you do if you completely forget the steps here?
You could do the... No.
How? How could you possibly find that x if you don't remember any of the steps?
You could use the exponent properties to move the...
That's the strategy. Say you forgot that.
You should Move the exponent.
Say you forgot how to do that.
What? Well,
You-
then I
there's
can't help
so
you.
many
Is
too.
the answer to isolate x, or did you forget how to do
Say you forgot how to do that.
Just answer it like I can't.
I'm trying to find a value that makes this true. What could I try?
Simon and Joe.
Just plug stuff in and try to find something that makes it true, right? Let me try 5. Let me try 6. Let me try 10, right? So you always have that in your back pocket, and I don't want you to forget that, right? I'm going to give you strategies all the time, right? But don't forget like what you're trying to do so that if it comes up, you have a backup plan, okay? All right, now let's go with the actual strategy. So if I have this situation, well, we said we want to get x by itself, but sometimes x is inside like a locked box with an exponent on it, right? So we can't get x by itself. So we get that by itself, right? And then we can work with it. So what, right, do you remember this exact wording of this strategy? It was called isolate the square. We're going to change the wording a little bit now to isolate the power, because it's not just going to be squared up now. It's going to be to the third or to the 4/3, right? But we still want to isolate the power, okay? What's being squared here? This right here, right? So I need to isolate this pink part and get rid of anything that's not pink. So what needs to go away? 2. Okay, so let's be very specific here. Why am I dividing by 2? Because it was multiplying by 2. And I need to do it's multiplying by 2, and I'm dividing because that's the... Why does it cancel? Because it's the opposite. Big word today. Opposite, 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 opposite. Okay? I need to do the opposite. We always do the opposite to isolate our variable or to isolate our power. So I do the opposite. I think that through. What's the opposite of this? Well, it's multiplying, so I'll do the opposite. Okay? So I do that, and I get x minus 4 squared equals 36. Okay, now I'm ready to try to unlock that box that the exponent is holding hostage. So I need to do what to get rid of that exponent? I'm going to square root it. Why? Because it's the opposite, right? It's the opposite of squaring. So I will square root it. And then I get x minus 4 equals...
6, plus or minus 6.
Very good, because when we're solving, we account for every possible solution. So plus or minus is back. It comes into play, okay? Now, what do we know is true here? 2 things I know to be true. There's going to be 2 answers. We know that a couple of reasons. I got a plus or minus. That's kind of like a clue. Also, it was squared. That's another clue that I might have 2 solutions. There are 2 statements I could make right now. Remember, the equal sign is a statement. Why can I make 2 of them?
Because there are 2 different forms.
Because there's 2 things on this side, right? So somebody tell me one of the statements I can make.
X minus 4 is equal to positive 6.
X minus 4 equals positive 6. What's the other statement I could make? X minus 4 equals negative 6. Okay, now I'm going to do what to each side of both of these? What do I do? I add 4. Why? Because it's the opposite. And I get x by itself. So I just did a ton of opposites, and I got x by itself. Opposite, 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 right? Okay, well, how do I know these are solutions to this?
Because it's x equal to something.
That's not the reason I know it's a solution. That's my result. How do I know 10 and negative 2? How can I feel confident?
Oh, you can play it back then.
They make it true. 10 minus 4 is 6. 6 squared is 36. 2 times 36 is 72. Same thing if I plugged in negative 2. Okay, so rather than write every step and blah, 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 I'm going to write one big word. Opposites. How did we do this? Opposites. Over and over and over again. Okay? Now, let's talk about opposites, right? So, for instance, the opposite of adding is subtraction, right? And you would do either to offset the other. The opposite of division is multiplication, right? You would do the opposite of other, whatever. Okay, what is the opposite of x squared?
It's the square root.
It's the square root of x, right? We can go either way to get rid of one or the other. What's the new way we know how to write that?
X to the 1/2.
X to the 1/2. Save that thought. X to the 1/2. Okay, x to the 1/3. The opposite would be to the... Oh, I'm sorry. I meant to say x to the 3rd. It would be the 3rd root of x, and that would also be x to the 1/3. So as a general rule, we know that if you have x to the n, the opposite of that is the nth root of x, or x to the 1 over n. Okay. Okay, so now before we get into some more solution, like harder ones, let's talk about some ones we can already do and just analyze a little bit the 1 or 2 solution situation. Because one of the biggest things trip people up here is not knowing when it's a 2 solution 1, when it's a 1 solution 1. Okay, so we're going to kind of try to make sure that we understand that. Now, if I wanted to solve this equation, x squared equals 64, what would I do? Square root. Okay, what do we say the other thing that's the opposite of x squared is?
X over
X to the 1/2, right? So if I raise this to the 1/2, is that the opposite?
yes.
All right, so it should work if I raise these both to the 1/2, right? Okay, so this would be power to a power, and this would be 2 over 1 times 1 over 2, so that's x to the
2 over
2 over 2 equals the square root of 64. And 2 over 2 is 1, so it's just x, right, equals what? Plus or minus 8. So this whole time we've been square rooting to get rid of a square. That's why it worked, okay? Because the power to a power makes it 2 over 2, which is 1, which isolates the x, okay? Now, how many solutions do I have here? 2 solutions. Because 8 times 8 equals 64, and negative 8 times negative 8 equals 64, right? Okay, how about this one? What would I do? Let's try to solve it in the same way. I would raise it to the 1/3. And that gives me x to the 3 over 3 equals the 3rd root of 64. So I get x to the 1, right? And then I get plus or minus what?
4. It's 4. It's there on the board.
Anybody have an issue with that? Well, how did we prove that the 2 solutions that we had before were true? Yeah.
Oh,
Yeah.
It's only positive 4, because if it was negative 4, then
It's only positive 4. Get your erasers out. Why? It's got one solution. Remember, think about what a solution is. Yep, go ahead.
because if you were to multiply negative 4 3 times, you'd end up with negative 64.
Yep. So case 1 would be 4 times 4 times 4, which sure is 64. And then case 2, so that checks, is negative 4 times negative 4 times negative 4. Negative times a negative is a positive times another negative is a negative. That does not check, okay? And we wanted a value that makes this true. If I put in negative 4 here, I would not get 64. So it's not true. Now, what have we learned? What can we take away so we don't have to do this every single time? What's the difference between these 2 problems? Yeah.
If the power is an even number, then it's 2 solutions. But if it's an odd number, then it's 1 solution.
Correct. And I would actually take it further to say if you take an even root, you get 2 solutions. If you take an odd root, you get 1 solution, right? Yes, the power was what made us take the root, but the root's what's giving us the 2 solutions. So even root 2 solutions, right? And odd root will be 1 solution. And it might seem, okay, yeah, I get it, it's obvious, right? But when you have something to the 2/3, you have to pay close attention to what the root part is, whether it's even or odd, and that'll tell you how many solutions you can expect, okay? All right, so look at these real quick, and let's just make some predictions. 4x to the 5th equals 128. How many solutions do you expect? 1, because what type of root would I end up taking here?
5.
The 5th. X plus 5 to the 4th equals 16. How many solutions should I expect? 2. All right, see what you get. Go ahead. What? What is 128 divided by 4? Did I mess up the number here? It's 32, yeah. So I have x to the 5th equals 32. And now I would say
Okay, I got
5th root, or x to the 1/5. I should have been consistent with that. And then that gives me x equals, and then plus or minus, or no, just 2. Because negative would give me a negative 32. Okay. Here, well, it's already isolated, so I just take it to the 1/4. And that 4 to the 1/4 becomes 1, right? You see that? And I just get x plus 5 equals, and then I take the 4th root of 16, which is, what times itself? 4 times gives you 16.
No, it's a decimal point. Hold on. Oh, yeah.
It's plus or minus 2.
Okay.
So when we do even numbers, it's plus or minus, and when it's odd, we do.
Exactly.
Move the 5.
Well, we're not done yet. So now I have 2 statements that are being made, so I break it apart, and I say, well, that means x plus 5 equals positive 2, and x plus 5 equals negative 2, right? Isolate the x in both situations, minus 5, and I get x equals negative 3, minus 5, x equals negative 7. 2 solutions, right? If you want to check if you did them right, well, negative 7 plus 5, that's negative 2. Negative 2 to the 4th is 16. So you can always check. All right. Now, I want, here, let's see, fill in these fractions. I'll give you a minute to do it. You're trying to get 1. We're hammering this point home. You're trying to get 1 in each situation, right? Trying to create fractions that will get you to 1. Remember the word reciprocal? It's a fun one, right? It's just the opposite flipped fraction. We use it, we multiply by it to get to 1, right? So 2/3 I'd multiply by 3/2, which is 6/6, which is 1. 4,
Over 1.
very good, over 1, the opposite of that is 1/4, which would give me 4/4, 1. Now this is how we use it, right? I want to get x to be x to the 1, right? I want x by itself, just x. So I'd raise it to the 6/5, which would equal 30/30, which is 1, which is x. We see how this works? Okay, so now we're going to use that to solve some problems. Okay? So, try these. So use these. I'm going to let you try all 3, and then we'll go over them, and then I'll hand out your homework, and you'll have a lot of time to work on it. Okay. All right, let's look at this example real quick. Now, it's all about isolating the power, right? What's being raised to a power here? X plus 3.
Over 4.
By the way, how many solutions do we expect?
2.
2, right? It's nice to make that prediction at the beginning so you can kind of be prepared. Now, what needs to go away that's not pink? 2 and 1. If this was like 2x plus 1, what would you get rid of first? The 1, right? You would add or subtract before you multiply or divide. So I minus 1, and I get 2x plus 3 to the 4 equals 32, right? Now I would continue to isolate this, right? So I have to get rid of and the opposite of multiplying is dividing. So I divide, and I get x plus 3 to the 4th equals 16. Okay, well, to the 4th, we now know we can raise it to the, what? 1/4, right? If I raise it to the 1/4, well, 4 over 1 times 1 over 4 is 4 over 4. That cancels, and I get x plus 3 equals, and then I have 16, the square root of 16. I mean the fourth root, sorry, the fourth root of 16. Yes.
Plus or minus 2.
This 4 and this 1/4, because it's power to power, so it would be 4 over 1 times 1 over 4, which is 4 over 4, which is 1. Okay? What is the fourth root of 16? Plus or minus 2, right? So that means x plus 3 equals 2, and x plus 3 equals minus 2, and that means minus 3, I didn't get this up. X equals negative 1. X equals negative 5. 2 solutions. Okay? Next one. Give it a shot. Hang in there. We're 2 problems left, then you get your homework. All right. So I'm going to isolate what's being raised to a power? X minus 1, right? We'll go yellow this time. So what needs to move away? What's the opposite of positive 5? Minus 5, right? We're not done. We just get tired. It's okay. X minus 1 to the 2/3 equals negative 3. Okay, so now I raise this whole thing. I want just x minus 1. So how to get rid of the 2/3? I do the opposite. I raise it to the opposite of 2/3. The opposite of 2/3 is 3 over 2. Right? Same principle. This is why we practice with 4 and 1 over. You didn't need that, but the skill is now in place. We can use it for these harder ones, right? Okay, so this gives me 6 over 6, which is 1, which goes away. So I get x minus 1 equals, give me a second, equals negative 3 to the 3/2. Okay, so what's my root here? In 2, and what's my exponent? 3. Okay, so I have, let's see, x minus 1 equals the square root of negative 3 to the power of 3. So now what?
You have to,
I times
you
the
can't
square root of
do
3
a square root of negative 3, so you have to separate it.
So this is what we'll do. For now, I'll just say no real solutions, okay? We'll get to the I.
Can we just leave it like this? Like, leave the root there?
All I want you to do right now is recognize that that's imaginary. Right? Can't take a square root, okay? We'll get there. Yeah, what's up? Square root. That's the second root. Yeah. You can write a 2 there if you want. All right. Last one. Do we need time? We're going to go through it. All right. So what am I isolating?
X negative 2.
To the,
Minus 2.
how many? Ooh, that was cool. How many solutions do we expect?
1,
Very good. Okay. So now what do I get rid of first?
2, 10.
Minus 10. And I got 2 times x minus 2 to the 3rd equals negative 16. Then we divide by 2. I got x minus 2 to the 3rd equals negative 8. Now what do I raise this to opposite that?
1 over 3.
Oh my God, I can't believe the teacher gave us 2 imaginary answers in a row. So now I'm going to get x minus 2 equals the 3rd root of negative 8. And I can't do that because we just said we can't take the radical of a negative.
So it's a no solution.
when you put it into the calculator.
Oh, wait.
It's like,
No.
because it's negative,
No, go back.
it should have solution.
Go back.
You could totally do it.
Yeah.
Negative
You
8 to
could
the
do it
1/3
because
is
it's
negative
3,
2.
3.
Yes, you can take, I was being facetious, you can take an odd root of a negative, right? Question.
I put down 3 over 1, and I got the same answer.
Well, we're not done yet. What do you mean you got the same answer? So 1 over 3 is what would counteract 3 over 1. So you need to do 1 over 3 on both sides, and that gives you the third root. And then you have x minus 2 equals what? This is the third root of negative 8. So what times itself 3 times gives you negative 8? Negative 2. And you can do that. Okay? Now I would add what to both sides? And I get x equals 0. Now, how do I know that's true?
Because you could plug it in.
Plug in 0, it will be true. Negative 2 to the third is negative 8, times 2 is negative 16, plus 10 is negative 6.